Okay, this is going to be blue because we're going to be angry about stuff, I'm pretty sure. Let's see. We build this thing. Old texture width does not equal texture width. Yeah. So if we go into our components, our static height map, creator is 512 by 512. Alright, well. If that is the texture, then is it because our texture regions or something like that where... Why don't we just do something intelligent here for a second? Let's just write out the color as like the actual location. And this will tell me, we're just going to write the X and Y location to the color, and that should give us something that goes from, what, black to red on the top, and then black to green on the left. So it'll go from black to red and green, so it'll go from black to yellow along the... Oh man. Alright, contacts almost totally screwed up. But yeah, I expect, I don't know, if we get everything working properly for this game, and like it's mid-range success, you know, like we make enough money to justify ourselves existing, I don't think I'm going to be an independent developer for like 10 years or something else. I like being in charge of shit too much. Yeah, so very clearly it has something to do with the texture that we're using here. So the question is, why is this like this? Is it when we create this texture region that our colors are wrong, or something else? Region num 0, pitch is 2048, source BP is 4 bytes per pixel, our data is our data. Regions is 0, 0, 0, 0, 5, 12, 5, 12. We'll see if we can actually breakpoint any of this macro garbage. So call stack is update all that stuff. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? So why would we be off by 16? I mean, 4 times 4 is 16 on this thing. Let's just look at this RHI update texture 2D docs. So it's supposed to take into texture, a MIP index, update region, source pitch. Alright, so the source pitch is size and bytes of each row of the source image. Update region, the rectangle to copy source image data from. Source image data starting at the upper left hand corner of the source rectangle in pixel format as texture. In same pixel format as texture. Alright, so this is, we have our texture region, which is 512. Bytes per pixel is 4 bytes per pixel times this is the pitch. That's the width of this, and we have our temp data, which goes all the way out. Number of regions is 1, pitch is 2048. So size and bytes of each row of the source image. So I mean that's 2048. Get texture, MIP regions, pitch, source data plus pitch times. Alright, so the last one is source image data starting at the upper left hand corner in same pixel format. So it probably has something to do with this calculation right here. So the We have the source data plus the region index. First MIP is going to be like blah, right? Let's go look at that example code that I saw. Let's look at my history real quick, and we'll take a look at that. Yeah, I think it was this dynamic textures. And then we also had this guy who actually implemented himself. Let's see what he did. Like, he's got this update texture regions function, and he's got 0, 1, 4 times texture size x for get type data, and then false for free data, source BP, source pitch, then regions. He's got this region index source y and source x. Source BPP is set in there. He did 0, 0, 0, 0, texture size x, texture size y. I mean, I don't... I mean, if I just grab like one of these geoplanes here, let me throw this up here. So we've got this boulder 01 material with this thing on it. Just gonna throw a copy of this texture, a copy of this material on here, and we'll mess with it real quick. So I'm just gonna call this test mat. So I'll throw this material on here, and let's just apply this and see how it looks. So we've got this texture, which is looking like what it should. And if I pass in text chord 0 to this thing, it looks like that. So our texture coordinates are fucked up. That is what's going on. Alright. I'm like, I don't see where this is wrong. Turns out it's wrong because this shouldn't be text chord 0. This should just be text chord like this. Right? Right? And this is the crap that I hate. Is like, I delete this node, and I save it, and I close this thing, and I reopen it, and the node's back. So let's save that and see if it actually saves. There it goes, actually saving. And there is our actual texture. Oh, why you gotta do this to me? Why you gotta do this? Well, that's why you test every little piece as you're going along. That way you actually know what the hell you're doing. And you're not just scratching your head for 2 million years. So text chord 0 is not the right thing for this. And let's go open up this mesh real quick. This geoplane mesh. And let's see, UV channel 0 UVs. Showing UV channel. Yeah, alright. UV channel 1. I don't understand. I don't understand how UV channel 0 is giving me a tiled thing. Is there something in this texture sample that, you know, when we did this, like we do a wrap or something? Like maybe there's... You know, I'll mess around here. I'll see if there's something weird going on. And that's like a clamp. No. Texture coordinate. Alright, here we go. Texture coordinate 0 has a tiling of 16 on it. Alright, so that's why it's messed up. Like, why is it tiling 16 times? I don't know why it's tiling 16 times. Oh yeah, check your texture coordinate. It says tile 16 times, you idiot. Alright, so let's go replace our... Let's make sure we save everything and quit here. And we're going to go back to our physics utils. And we are going to save our values in here and check them out. Make sure they work. So, and if you're wondering what exactly I'm doing, I'm creating a height map under the water with a specific resolution, which we can update whenever we want to, if we need to. And the question would be, well, why don't you just use like a distance field in Unreal, or why don't you use something else? And the answer to that is because the distance field stuff, as far as I saw, was not supported for a lot of objects, like the terrain. Landscape stuff doesn't work with it. And it also had some problems where like it didn't work except if you're on like a DX11 environment or specific NVIDIA cards or something. It's like, well, I don't want to rely on a feature like that for something like water. So let's just make our own custom solution. And if there's some other way to do it, I'm unaware of it. And that's okay. I don't have to be aware of everything. Alright, so we can see all of our normals and stuff like that coming up there. What the hell is that little circle thing there? Oh, that circle thing? Yeah, that's a mushroom. Alright, so we've actually got our data here for all this. Let's change our material real quick and look at our height map. So the alpha value should be our height map. So what I want to do is I want to make a float 3, and I want to just like set it to this value. Let's just see what that looks like. So we can see our height map here as this thing goes. We can see all of the values. Is that correct? Yeah, it looks right. Alright, so let's test a few things. Let's try rotating this object. Well, obviously this object is incorrect in its rotation. And I think I already said that we can't rotate in our z-axis, and that's exactly what I just rotated this thing by. So let's try rotating in our other axes. Let's try rotating like, in our x and our z-axis. Like that. Yeah, let's try this. So what we should see is let's see if we can get a better look at this. Doesn't look like it's really rotating properly, does it? Because like if this is a 0, it's going to be the same thing. Yeah. Does it rotate in the Y properly at all? A closer value to 0 is what it should look like. So what we'd expect it to get brighter as it gets closer. It looks like it's inverted there. Like you can see, like it's like dark over here, which means dark means a close value, and it's actually the furthest away. So we are I think we are inverted in some of our calculations for these things by our rotations. So let's take a look. We'd assume a value of, because this is all distance getting baked in here. So max distance is going to be white. So if we like threw this way up here, yeah, max distance is white and closer is black. So these should be all black here. Are we actually going beyond? No, it looks like we have proper collision. It looks like maybe these mushrooms are, they've got like a collision box on them that's kind of weird, like a big fat collision box on them. Definitely possible. Alright, so we'll have to deal with these rotations real quick here. So let's recalculate this stuff. Anyway, I'll be right back. Just need a minute. Alright, so let's take a look at these values real quick here. Calculate. Alright, so it's going to be the center minus the extents. The extents are 45315000. So we are fatter than we are wide, which is correct. So the top left is going to be the center minus the extents. So the top left is going to be at minus the extents, so it's going to be at negative 5,000 and then the extents x. So it's going to be at 4531 by negative 5,000. Alright, the top right is going to be center minus extents. Plus 2.0. Isn't this just center plus extents? Alright, that's true, and that's going to be 4531 5000. Alright, the bottom right is going to be center plus extents, but we're going to negate the x, so it's going to be negative 4531 5000, and our bottom left is going to be just center minus extents, which is going to be negative 4531 negative 5000. Yeah, that's correct. The X step, ignore. Jesus Christ, just. Visual Studio gets a little bit too helpful at times. I want it to just shut up and do what I want it to. Like, stop trying to be smart, Visual Studio. Just let me edit the code. I know it's different. I don't care. Alright, so the step is going to be top right dot y minus top left dot y divided by resolution. Okay. And the z step should be top right dot z minus top left dot z. Alright, z is positive, so we need to make sure that the z coordinate here is proper. So the top left corner of this thing if we are rotated, I don't really see exactly what this is going to look like, because it may be that our z is flipped on some of this. Arbitrary math. What are the extents? The extents are positive, so do we ever do a transform for this box? Like we have the extents, and do we ever transform? These are just the bounds. No. We're suffering from the same issue that we had before. Basically, the z needs to be 0, and we need to transform. Ugh, this is just an extents thing, right? So this isn't going to tell us which part of the box is where at all. We need the transform to tell us what this is. Alright, so basically we want an F transform equals this, and we're going to want just F vector top left, top right, bottom left, bottom right, and we're just going to define these things. This is going to be 0, 0, or top right is 0, 1, bottom left is at 0, bottom left is at 1, 0, or negative 1, 0, and bottom right is at negative 1, 1, and then we just say top left equals we want to rotate this thing by our rotation. And then we'll do rotate vector. And we do top left plus equals transform dot position. So that should give us like a better read on this stuff. And then we just have to get these top left rights and all that stuff set up properly for the model when it's at its origin. And I can probably just hard code those. Oh, that's just a public thing, not a function. Alright. I mean, that's a variable, not a function. Well, let's just relax. We don't have to do a whole bunch all at once here. Yeah, but the extents are basically the wrong solution. The extents are always positive, and that's not what I need. Because if the extents are positive, how do I know where everything is? Alright, so top left is at 0, 0. Top right is at 0, 1. Bottom left is at... We didn't take the scale into account. Yeah, so we should just be transforming the position on this thing is what I think. Like that. So we are able to rotate the vectors properly, but stuff was stupid. I just need to open up that mesh and see where the coordinates are for the top lefts and everything, and then I'll just hard code them in there, because just be like, use this mesh. That's the one that works. Now what is this grid here? It says approximate size 100 by 100. And it looks like that grid goes through 0, 0. So Z is up, X and Y. Yeah. And if it's 100 by 100, is it 128 by 128? I wish it would actually let me look at the raw vertices. What about this geoplane? This guy says its approximate size is 1,000 by 1,000. So if we swap out this plane here, which is this geoplane, we use water plane. It's much smaller and rotated strangely. Alright, well let's just change to using the water plane then. And let's make sure that our material is actually using the right thing here. So let's just do this. And that goes from 0 to 1. That's 0, 0. It goes from 0 to 1 like that? I need to stick with a plane. And that's just what we're going to use. So this one is actually opposite of what we were using before, where x is in the positive x actually goes in like 0 to 1, right? Because it goes u to v, so it's lined up properly. So we should definitely be using this thing as opposed to the other. Alright, so we're going to try negative 50, negative 50. Yeah, so the top right's going to be at negative 50. Actually, I guess the top left and top right are at 50. And then it goes from 50 to negative 50, or negative 50 to 50 in the y. So bottom left is going to be negative 50, negative 50. And it's going to go from negative 50 to 50, like that, I believe. This is why we've been doing a lot of work inside of blueprints as well, so you don't have to compile stuff every 5 minutes and wait for the editor to relaunch and all that sort of stuff. Alright, looks like it's rotated the U and V are rotated? Well, they're flipped. Not rotated, they're flipped. Alright, so we just need to flip these axes here. Alright, let's run it and see what we get. Alright. Well, that didn't work at all. Can you flip everything?